In this video, we are going to learn how domain-driven design and microservices work together. Domain-driven design and microservices are two concepts that complement each other when designing and building complex software systems. Here is how they relate and how they are applied. When we take a look at domain-driven design, it's an approach to software development that focuses on understanding and modeling the business domain. It encourages collaboration between domain experts, software developers, and stakeholders to ensure that the software aligns closely with the real-world domain it serves. So, there are some key concepts of domain-driven design. One is ubiquitous language. It's a shared language and glossary that domain experts and developers use to discuss the domain model and its concepts. So, next one is bounded context. It's a dividing a large complex domain into smaller, more manageable bounded contexts, each with its own distinct model. This helps in keeping models focused and cohesive. Next one is aggregates. These are clusters of domain objects treated as a single unit. Aggregates enforce consistency boundaries within the domain model. So, next one is entities and value objects. These are representations of domain concepts. Entities have identities and life cycle, while value objects are immutable and defined by their attributes. Next one is domain events. It's a capturing significant changes in the domain as events that can trigger actions across different parts of the system. Next one, we take a look at integration of domain-driven design with microservices. When applying domain-driven design within a microservice architecture, there are several considerations and practices emerge. One is bounded contexts as microservices. So, each bounded context in domain-driven design can be implemented as a microservice, encapsulating its own domain model, logic, and data storage. Next, ubiquitous language across microservices. So, each microservice should maintain a consistent and shared understanding of the domain language, ensuring clear communication between teams and stakeholders. Next one is service autonomy. Microservices maintain autonomy in their design and implementation, aligning with the principles of bounded contexts in domain-driven design. Next, consistency through integration. Use integration techniques such as event-driven architecture, such as using tools like Kafka or RabbitMQ, or API orchestration to maintain consistency and coordination between microservices. And next one is domain events and transactions. Use domain events to propagate changes and maintain consistency across bounded contexts. Ensure transactional consistency where necessary, often through compensation, transactions, or eventual consistency patterns. There are some benefits of domain-driven design. One is scalability and agility. Microservices allow teams to independently develop, deploy, and scale services, promoting agility and faster time to market. Next, domain alignment. Domain-driven design ensures that the software closely mirrors the real-world domain, improving understanding and maintainability. And isolation and resilience. Fault isolation and resilience are improved as failures in one microservice do not necessarily affect others. And challenges. So, one challenge is complexity. Managing a distributed system introduces complexity in deployment, testing, and monitoring. Next one is consistency and transactions. Ensuring consistency and maintaining transactions across microservices can be challenging. In conclusion, Combining domain-driven design principles with a microservices architecture can lead to systems that are well aligned with business needs, scalable and maintainable over time, albeit with careful consideration of the added complexity and challenges involved. In this video, we are going to take a look at entities in domain-driven design. Entities are key objects that have a distinct identity and life cycle. Entities include methods. Entities are not just data containers, they encapsulate both data and behavior. In this example, order is an entity with an identity, which is order ID. It encapsulates business logic related to orders, such as adding order items and calculating total amounts. Order item is a value object associated with an order, representing items added to an order. It doesn't have its own identity outside the context of an order. Entities in domain-driven design encapsulate business logic and maintain consistency within the domain model. They typically have methods that enforce business rules and ensure that the object remains valid throughout its life cycle. In this video, we are going to take a look at value objects in domain-driven design. So, value objects is an immutable type that is defined not by its identity but by its attributes. Value objects are often used to represent concepts that don't have a distinct identity and where equality is based on the state of the properties rather than on a unique identifier. So if we take a look at the value object example, here it is money value object. There are some key characteristics of money value object. One is immutability. Value objects should be immutable, meaning that once they are created, their state cannot be changed. This guarantees that the value represented by the object remains consistent and reliable throughout its life cycle. The other one is equality. Value objects are compared based on their values, not their identity. Two money objects with the same amount and currency are considered equal, even if they are different instances. The other one is encapsulation of business rules. The money value object can encapsulate business rules related to money operations, such as ensuring that arithmetic operations only occur between amounts in the same currency. The other one is behavior and operations. Value objects can have methods that define behaviors and operations related to their role in domain, such as addition, subtraction, and comparison of monetary values. So, by using a money value object, you can enforce business rules, maintain consistency, and ensure the integrity of monetary values within your domain model. In this video, we are going to take a look at aggregates in domain-driven design. Aggregate is a pattern that helps manage complexity in a software system by grouping related entities and value objects into a single unit of consistency. Aggregates ensure that business rules are consistently enforced across related objects and provide a clear boundary within the domain model. Here we have aggregate concepts. One is aggregate root, the main entity within an aggregate that acts as the entry point here, aggregate root. All access to the objects inside the aggregate should be through the aggregate root. It ensures the integrity and consistency of the aggregate as a whole. Next, bounded contexts. A boundary within which a particular model is defined and applicable. Aggregates exist within a bounded context, helping to manage the relationships and interactions between different parts of the system. And entities and value objects. These are aggregates can contain both entities, objects with a distinct identity, and value objects, objects defined by their attributes. Here we have aggregate example. In this example, there is aggregate root, which name is order, and Entities within the aggregate are order item and shipping address. And value objects within the aggregate, money and product details. So if we take a look at operations on the aggregate, one is create order. The creation of an order is managed by the order aggregate route. And add item to order, this operation is handled by the order aggregate route, which ensures that the item can be added and the total amount is updated correctly. And change shipping address. The order aggregate route ensures that changes to the shipping address do not violate any business rules. In this video, we are gonna take a look at bounded contexts in domain-driven design. Bounded contexts are a strategic design pattern used to divide a large domain model into smaller, cohesive parts. Each bounded context represents a specific area of the business domain and contains its own domain model, which encapsulates the entities, value objects, domain logic, and relationships relevant to the context. So here we have an example for the bounded context. In this example, order management has entities. Entities are order, payment, customer, and value objects are address, money, and domain services, order service, payment service. So there are some key points of bounded context. One is separate projects or namespaces. So each bounded context might be implemented in separate projects or namespaces within the C# solution, ensuring clear separation and modularity. The other one is contextual services. Each bounded context has its own ubiquitous language, which means the terminology used within the context is precise and consistent. Next, contextual entities and value objects. Entities and value objects are tailored to the specific needs of each bounded context, reflecting the domain terminology and requirements. In this video, we are going to take a look at domain events in domain-driven design. So domain events are an integral part of domain-driven design and represent significant state changes or meaningful occurrences within the domain. They capture these occurrences as objects in code, allowing different parts of the system to react or respond accordingly. So if we take a look at example for domain events, you consider an e-commerce system. When an order is placed, order placed event, it triggers processes such as sending a confirmation email to the customer, updating inventory, and logging the transaction. Each of these processes may be handled by separate components or services listening to the order placed event. So in terms of implementation, domain events are typically simple objects with relevant data fields that describe the events. They are raised or published by the domain entities or services when certain conditions are met, allowing other parts of the system to subscribe to these events and react accordingly. Domain events in domain-driven design provide a powerful mechanism for capturing and reacting to significant changes within the domain model, promoting flexibility, decoupling, and alignment with business requirements.